often misunderstood topics of abortion, fetal tissue research, and stem cell research. Before I go any further, I would be remiss if I did not make mention of last week's tragic shooting at a Colorado Planned Parenthood, as we are going to be talking about Planned Parenthood today. The Family Research Council, and I'm sure I can speak for Dr. Prentice as well, in saying that we condemn in the strongest terms the actions of the shooter. Nothing less than a completely pro-life ethic will stand in this conversation, and our prayers continue to be with those affected. I first met Dr. Prentice 5 or 6 years ago here at FRC when I first graduated with my degree in bioethics, and I was considering how I might use my training to enter the policy realm. And you may not even know how instrumental you were to starting me down the path that ultimately led to me being here, and so I want to say how grateful I am for your encouragement and your advice and your prayers. A couple of housekeeping items, that's usually my task. I just wanted to welcome those of you who have joined us online. We're glad you're here. And also wanted to remind everyone here and watching at home that we do archive all of our lectures on our website and on YouTube, so please do share the link after we get to enjoy this excellent lecture. So at this time, I do want to introduce our speaker. Dr. David A. Prentice is one of America's most distinguished bioethicists and stem cell experts. Currently Vice President and Research Director for the Charlotte Lozier Institute, he is also Adjunct Professor of Molecular Genetics at the John Paul II Institute, the Catholic University of America, and an advisory board member for the Midwest Stem Cell Therapy Center, which was developed under his leadership. Previously, he served 10 years as Senior Fellow for Life Sciences here at the Family Research Council. Dr. Prentice received his PhD in biochemistry from the University of Kansas and was at Los Alamos National Laboratory and the University of Texas Medical School, Houston, before joining Indiana State University, where he spent almost 20 years as professor of life sciences, and Indiana University School of Medicine, where he was adjunct professor of medical and molecular genetics. He was selected by President George W. Bush's U.S. President's Council on Bioethics to write the comprehensive review of adult stem cell research for the Council's 2004 publication, Monitoring Stem Cell Research. Would you join me in welcoming Dr. Prentice?
Well, thank you all so much. It's great to be back at FRC. A lot of very familiar faces out here. I'm going to spend some time today going through some slides very fast, but as Bethany said, they will be archiving the talk, so if you need to review later on, that possibility will be there. But there's a lot of ground we need to cover in terms of the ethics as well as the science and the medicine involved in fetal tissue research, abortion, and especially stem cell research, embryonic and adult. And I just want to go through a few basic facts at first. Number one, Planned Parenthood does abortions. Now, for most of us listening to the lecture, this is something we've known a long time, but it turns out at least half of the American public don't know this fact. And in fact, if you look at the number of abortions, a little over 327,000 in a year. If Planned Parenthood were a country, it would be the 6th leading country in the world in terms of number of abortions. That's a lot of abortions. Another fact, it's pretty well funded. There's been a lot of discussion and debate about the government part of that funding, a little over $528 million in state and federal government funding, but their total revenue is $1.3 billion. And for a nonprofit, they actually end up having a fair amount of what they call excess revenue. Over the past decade, about $750 million in excess revenue. There are alternatives, and this doesn't often come out in the debate fully, but when people start talking about, well, women need these health care choices like Planned Parenthood, it turns out there are 20 times as many non-abortion providers that offer women's health care. We've worked together with Alliance Defending Freedom to put together maps and locate a number of these different federally qualified health centers, rural health centers, and so on. I'm showing the map up here now of Maryland. You can see the number of Planned Parenthood facilities around the state versus the number of community health centers. Quite a few more of the non-abortion providers available to provide comprehensive women's health care, including actual mammograms. Virginia, the same sort of thing. 25 community health care clinics for every Planned Parenthood health clinics. And especially if you start down here and look, there's a big area of Virginia not even covered by Planned Parenthood, but ample coverage by these community health centers. And we've actually made this into an interactive map, the website getyourcare.org, where someone can go in and actually put in their zip code or zoom in and find a number of different community health centers very close to them. I want to switch now and talk a little bit more about the ethics of abortion, ethics of fetal tissue, and I'm putting up here just a little quote from the Hippocratic Oath. I'll neither give a deadly drug to anybody if asked for it, nor will I make a suggestion to this effect. And similarly, I will not give to a woman an abortive remedy. Way back in Hippocrates' time, the recognition that this would be promoting death of a human being in either of these cases. So let's talk a little bit about the biology. This is actually from one of the two leading scientific journals in the world, Nature, a number of years ago, and I just like the title, Your Destiny from Day One, because there's a recognition, at least in science, in embryology, that that is when your life began, at conception. I want to show you some other stages here, what are called Carnegie stages in embryology, but you can see as you develop, you start to take on more definitive forms till finally over here at about 8 weeks, you look pretty much as you do now in terms of your limbs and proportions and so on. But here are also targets of abortion. And here are some more at 14 weeks, at 18 weeks, at 20 weeks. Some pretty recognizable faces that we can identify with. Still targets of abortion. I want to show you some more faces. Potential targets of abortion. Micah Pickering was born at 20 weeks post-fertilization. Something that not that many years ago would have been thought impossible. And there's a real lesson to be learned here in terms of our attitudes about young, unborn lives. Because this whole question about viability, could you survive outside the mother's womb? Science and medicine keeps pushing back on that. There's a study in the New England Journal of Medicine not that long ago showing that, yes, even at 20 weeks post-fertilization, these little ones can survive. And what the authors noted was, if a doctor takes an attitude that, yes, they can survive, they tend to survive much better than if they take an older attitude that they're just too young to survive. So that if they just did simple types of interventions to help them breathe, they would survive. Micah was up here recently on Capitol Hill. Here he's high-fiving Senator Joni Ernst. But he is a face in terms of this debate. Someone that in a lot of cases would have been aborted, but he is alive and thriving. Here's another, not a face, but a hand. You might recognize this little hand. Samuel Armas, famous picture of the little hand grabbing the doctor's finger, or at least held by the doctor's finger, out of the womb, having surgery, fetal surgery, at about, frankly, 20 weeks. And there are now several thousand individuals who have been isolated in the womb, operated on with this fetal surgery for various conditions at a time where it is still legal in the U.S. to abort them instead. I want to talk a little bit more now about the fetal tissue. And this is a consent form from one of those clinics featured in the Center for Medical Progress videos, Marmonti Clinic. And I want to point out this very first sentence here, that a woman has come into the clinic, has declared that she wants to get an abortion. She's given this because they want to consent to get the fetal tissue from the aborted child. Notice what it says. Research using blood from pregnant women and tissue that has been aborted, that's sometimes called an unborn child, has been used to treat and find a cure for diseases like diabetes, Parkinson's disease, Alzheimer's disease, cancer, and AIDS. Now, if you're surprised to find that fetal tissue has been used to treat and cure these diseases, you wouldn't be alone, because it's simply not true. But this is the type of misleading information that's often given out at Planned Parenthood or other abortion clinics when, if they're asking consent, they're trying to get the consent from the woman to get the tissue. You know, there's been a lot of so-called justification, I guess, to use that fetal tissue to try and put a good positive glow on it. And I want to go through what are the three main justifications we've been given and really dispel a lot more myths. Number one, transplantation, that you're going to transplant and cure all these various diseases like diabetes and so on that were mentioned in the consent form. Well, they did try over many decades to use fetal tissue in transplant for various diseases. Even back in the 1920s in the UK, Italy, in the 1930s in the US, all those transplants failed, no matter what they were trying to treat with this transplant of fetal tissue. Patients have even been given fetal tissue into their brain, and instead of treating the patient, they formed what the authors of the paper called non-brain tissues. Things like bits of bone and other things growing in the patient's brain. Not exactly a help. In 2001, there was a report on a very large controlled clinical trial trying to treat Parkinson's patients, again with fetal brain tissue. It made the New York Times because the doctors described their patients writhing, twisting, jerking with uncontrollable movements, that the results were absolutely devastating, tragic, catastrophic, and a real nightmare. Not a very successful treatment or a cure, I guess. 2003, a second big trial. Over half of the patients had potentially disabling tremors. We've seen reports using fetal stem cells, where these cells, instead of successfully treating the patient, cause tumors. Now, there are ethical and successful alternatives, and we'll come back and talk about them a little bit later, the adult stem cells, for example. What about vaccines? This is one that's also been trotted out in terms of fetal tissue has been so important in production of vaccines. Well, there's a tiny little raisin of truth in that great big pudding that's out there. Yes, they were first able to grow poliovirus, for example, using aborted fetal tissue back in the 30s and 40s. And then they switched to what are called cell lines, where they've taken a group of cells and gotten them to grow in the culture dish and continued that growth over the years. But it turns out the original Salk and Sabin polio vaccines didn't use fetal tissue. They used monkey tissue. And in fact, most vaccines, certainly most polio vaccines, but most vaccines in general nowadays, number one, don't use fetal tissue at all, and number two, rarely use even these old cell lines from the 1960s and 70s. Instead, there are newer and better ways to make vaccines that don't involve the death of another human being. The CDC has even said there's no new fetal tissue needed to produce cell lines to make these vaccines now or in the future. That was a statement made in 2001. And then finally, basic biology research, sort of the catch-all. And what you'll always hear is, well, we've got potential cures coming, potential treatments, if only you'd let us do this research. Well, it turns out it's still antiquated science. The golden age of fetal tissue, if there was one, was in the 1950s and 1960s. And it's been downhill since there. You might hear something about a humanized mouse, and before you get an idea of Mickey Mouse or something walking around, what they're doing is they're replacing the mouse's immune system with human tissue to make a human immune system so they can test various vaccines or infectious disease agents and so on. And yes, they do use fresh fetal tissue for some of these experiments, but it turns out you can get even better results by using licit types of cells like adult bone marrow stem cells or even umbilical cord blood taken after the baby's born. You can do modeling much better with what are called induced pluripotent stem cells, and we'll discuss those in a little bit as well. And then there are even, in terms of getting parts of organs, they're starting to develop what are called organoids. And these are bits of organs, not maybe a complete organ, but partial organ formation that you can get, but you get them with adult stem cells or these induced stem cells. And I put this slide up. I don't know if you've seen the videos, including the first one where they mentioned there was a demand for fetal liver. Why is there a demand for fetal liver? Well, it turns out that at that point in your life, between about 8 and 20 or 24 weeks, you don't have bone marrow, you have liver as your source of blood cells and your source of your immune system. And after that point, the cells pack up their little cell bags and they move to the bone marrow and take up residence there because now the bones have formed and there's actually a place to take up residence. But it turns out that those fetal liver stem cells are essentially the same as an adult bone marrow stem cell. So you can do exactly the same thing you might want to do with fetal liver stem cells with bone marrow and cord blood. I want to talk a little now more about the stem cell debate, and this cartoon kind of captures what we had been told for years and years and years. So the guy on the left goes, I died waiting for embryonic stem cell research to find a cure. What about you? The guy on the right, I was the embryo. And we were sort of pushed out here with this, you've only got the two choices, right? You either let patients die or you kill embryos so you can get all those cures and so on. Well, there are other alternatives we'll talk about, but you kept hearing this hyperbolic rhetoric over and over. Former Senator Specter, embryonic stem cells are a fountain of youth and they have the potential to cure all known maladies. And when I heard that, I thought, what about dandruff? Former Speaker of the House Pelosi, science has taken us to a place that is biblical in its power to cure. It's embryonic stem cell research. It's the answer to our prayers. And current NIH Director Francis Collins, it's important life-saving research. Now, being a good professor, I need to give a pop quiz. How many lives have been saved by embryonic stem cells? Zero. Nada. Nothing. It's not working. And it hasn't worked for years. But we still were getting this push. You had to fund embryonic stem cell research. You had to destroy young human embryos to get these cells. Now, let me back up just a step and talk about when somebody talks about a stem cell treatment, what do they really mean? They usually don't mean growing a whole heart or liver or a lung in the lab and then transplanting that out like swapping parts in a car. Instead, it's what we're terming regenerative medicine now, where you would take in this diagram adult stem cells from bone marrow, inject into a damaged heart, perhaps after a heart attack, and regenerate, kind of repair or replace that damaged tissue. Any stem cell we talk about, up here at the top, has two chief characteristics that make it a stem cell. The little circular arrow there on the left, they keep growing and dividing, so you've always got a pool of cells available, whether that's in your body or in the lab dish. And number two, if you give a stem cell the right signal, the arrows out to the right, they will specialize or differentiate into any of the various cells of the body. But there are different sources of stem cells. So down here at the bottom, the human developmental continuum, as I've called it, you start here as a single-celled embryo, and after about a week, that's how you look. You look kind of like a ball of cells or a ball with cells inside. And that's the target for those who want embryonic stem cells. You have to destroy this young human being to get embryonic stem cells for their experiments. You can go farther out, and as we've discussed, you can have fetal stem cells later on in development. From birth onward, we just kind of ingloriously lump these together and call them adult stem cells, but babies have adult stem cells. You're born with them in your tissues and organs. You don't have to be 21 years of age to own an adult stem cell. They're in umbilical cord blood and even the solid part of the cord. Those are the ones that are actually succeeding where the others have failed. But we still kept getting these stories. So in 2004, when President Reagan died, we heard, well, if only we had funded embryonic stem cell research and done all this, he wouldn't have died of Alzheimer's. Well, of course, that was false. And interestingly enough, a scientist at NIH sort of broke that code of silence in science and admitted, well, they really weren't aggressively trying to tamp down that rhetoric because, as he said, people need a fairy tale. They need an easy story to follow. Well, we're going to cure all known maladies with embryonic stem cells if you just give us enough money and let us kill enough embryos. There actually have been a couple of human embryonic stem cell trials where patients were injected with human embryonic stem cells. No, it's still zero. Nobody has improved. But the first approval was actually given, coincidentally, I'm sure, a few days after President Obama was inaugurated. This company, Geron, wasn't so much interested in the approval as the fact that their stock price went very high after this approval. For a year and a half, then they were put back on a safety hold by the FDA. They did finally get approval in fall of 2010 to start injecting patients. In the course of a year, they injected 5 patients, none of whom got better, and then they finally gave it up because nobody got better and they weren't going to make any money off of it, and they were a little afraid that if they kept going, someone would have a problem, whether it's a tumor, a cyst, something else. They haven't even published the results because there's nothing to report other than the negative. But in some of their communications, they've talked about that there were no significant adverse events, whatever significant might mean to you and me. We still get the hyperbola. So here was a report, the scientific paper published a year ago about a lab at Harvard who had incrementally increased the number of insulin-secreting cells that they could grow in the lab. They didn't even get a pure culture of these cells. Most of the cells still were just growing, potentially would form a tumor and so on. But the news headlines were, a cure for type 1 diabetes is imminent. There's a breakthrough using stem cell research. There's a hope for a cure. They make a breakthrough in treating diabetes. They didn't treat anybody. They barely treated a few mice, and most of those mice died. This is not working. You don't have to kill young human beings, though, to get effective stem cells. And it was interesting, a few years ago, even a number of the leading scientists in the embryonic stem cell and cloning category were saying there's a better way to do this. Ian Wilmot is Dolly the cloned sheep's daddy. He's the one that cloned Dolly. He went to California where they had passed a budget amendment to provide 10 billion state taxpayer dollars and devote it to embryonic stem cells and cloning, and said, we need to do something else. That's not working. He had a license in the UK to actually create cloned human embryos for experiments. He gave back the license. California hasn't talked about how they're switching, but where they're giving their money has switched, and what you can see is they started giving all their money to embryonic stem cells and cloning. Now most of the money over the last few years has gone to adult stem cells. Why? They're going to need to come up with another budget amendment soon, and if they want to get any more money, they need to make good on their promises to provide cures and effective treatments, and only the adult stem cells are doing that. You know, just to reemphasize again, where are they getting those embryonic stem cells? From the little embryos, and I think this is pretty accurate. They're all carrying pro-life signs as he looks at them under the microscope. But here are a couple of former frozen human embryos. So this is from a 2001 House hearing. Mom here at the end of her testimony holds up a picture of these little thawed former frozen embryos under the microscope. And then John stood up with Luke and Mark in his arms just a few months later than this first picture was taken, and asked, so which one of my sons would you kill for research? Because that's what you're really talking about with embryonic stem cells. One or more of these individuals, thousands, millions perhaps, being sacrificed for embryonic stem cell research. I'd be remiss if we didn't mention cloning at least once more. They're actually creating human cloned embryos now in the United States. There's a lab in Oregon, there's one in New York State, another one in California. But these particular clones are not destined to be put in a womb and gestated to birth. They're used as raw materials for experiments, and frankly, nothing's coming of this either. So let's talk about the alternatives, the successful and ethical alternatives. Here were a number of headlines in November 2007. Human embryonic stem cells without an embryo. Skin cells transformed, bypassing the need for an embryo. And it turned out a Japanese scientist, Yamanaka, had found that he could take an ordinary skin cell, not a stem cell of any kind, but add a few genes and transform or reprogram, almost like reprogramming a computer, that skin cell so that it looked and acted like an embryonic stem cell. But there are no embryos here. There's no eggs. There's no cloning. You just go directly, kind of like Monopoly. Do not pass go. Just go directly to not jail, but a useful stem cell that has all the characteristics that supposedly you might be after as a scientist, but without destroying any human lives. Yamanaka won the Nobel Prize in 2012 for this discovery. It's interesting, he was asked by the New York Times, why did you even think about doing this? Add a few pieces of DNA and reprogram. And he said, I went to a friend's lab, looked through the microscope at some human embryos there, and when I saw the embryo, I suddenly realized there was such a small difference between it and my daughters. He's got 2 small daughters. Thought, we can't keep destroying embryos for our research. There must be another way. And there is. These are those induced pluripotent stem cells. You transform them, but you start with just an ordinary cell. And again, they look and act like embryonic stem cells. You can do any of the experiments you might want. In fact, they're better because you can make them from anybody. You can make them from patients who have a disease and study that disease in the dish. You can use them to model different things. You can use them to make some of those organoids to try and study things in the lab. Now let's talk about adult stem cells, another ethical alternative. And this cartoon is kind of capturing what we kept hearing. So this guy down here goes, you can either tempt fate in one of these death traps, or I'll show you the future of aviation. Well, like Icarus, this is not going to work. And instead, we're looking at a new paradigm in biology now, moving quickly along. So in red here are some of the tissues where we now know you can get adult stem cells. In fact, pretty much any tissue is what we're finding. But bone marrow, obviously, but brain, muscle, cord blood is a rich source of adult-type stem cells. Even liposuction fat. Now, if we needed an unlimited supply of stem cells, I can certainly get a twofer off of this one. In black are some of the types of cells you can make out of these adult stem cells. They are very flexible. You can make lots of different tissues and repair lots of different tissues because ultimately that's really where we're headed. You want to help patients. You want to repair damaged tissue. There's one reference a few years ago in the Journal of the American Medical Association just talking about the great successes of these adult stem cells from bone marrow or other tissues, how it's become the standard of care for many patients with a number of diseases and starting to be used for many, many more diseases. In fact, they said, quote, it demonstrates it's an accepted therapy worldwide. This paper in Lancet was published just this year and documented that there were over 1 million patients that have now been treated with adult stem cells. That was actually only through the end of 2012. Well, we're 3 years beyond that now, so it's at least 1.25 million patients that have been treated. Not lab mice, not experiments, people that have been treated with adult stem cells of different kinds. There's a website actually that FDA and NIH run called clinicaltrials.gov. You can go there and start a search for different types of clinical trials that you might be able to get into, different diseases that they're looking at. And I'll show you a website at the end so that you don't have to necessarily go here and try and figure out your search function. We've got that a little more streamlined for you. But when I checked, this was a couple of months ago, there were over 3,200 trials ongoing or completed already with adult stem cells. This is one of the doctors who's actually using adult stem cells now with patients, Dr. Richard Byrd at Northwestern University. I love his sign, though, Stem Cell Research, the Potential for Patients. And he's talking about adult stem cells, not embryonic, not fetal tissue. And I kind of want to finish up by going through a bunch more faces. We talked about faces in individuals earlier. Here's some more. Carol Franz, she likes to call this her before and after treatment. She had multiple myeloma. It's a type of bone marrow cancer that eats your bones from the inside out. She said her x-ray looked like she'd been shot with a shotgun. Well, she was treated with her own adult stem cells a number of years ago, and instead of the 6 months to live they had given her, lived 6 years longer. She also illustrates another problem in terms of getting people to realize that adult stem cells are even out there and working. Once she was diagnosed, the first oncologist she went to, she'd done a little checking on the web, and she goes, "Hey, how about getting me a stem cell transplant?" And that doctor said, "Those are decades away." He's thinking embryonic. Well, so she got a second opinion. The second oncologist goes, "Oh yeah, there's a clinic over here in the next town. You go in there. We'll take out 2-3 bags of bone marrow adult stem cells, throw them in the freezer. We'll zap you with chemo to kill the cancer, and then a 15-minute IV drip to give you back your adult stem cells." And you can also, she was kind of shrinking violet. Fluorescent shirts, adult stem cell transplant. Some versions said not embryonic at the bottom. She was from New York State. We took her up to the Hill once, and she almost killed Senator Schumer in an argument. Had to pull her off of him. Some other examples. Helen Thomas here was treated for peripheral artery disease. Your arteries and vessels get blocked in a leg. You've got no circulation. What's the usual recourse? Amputation. Well, they tried something else with Helen. They took some of her bone marrow adult stem cells, injected into the leg, grew new blood vessels. She walked out of the hospital and was dancing with her hubby. Cord blood. We need to mention that and mention that again and again, because umbilical cord blood is, number one, a rich source of these adult-type stem cells, and it's being used, but it also, because you don't always have to have an exact match, you can help out people, especially with minority needs, that might not have a match in the bone marrow registry. So we need to keep banking more and more umbilical cord blood. There are a whole host of patients who were treated with cord blood for different leukemias and anemias. This young man here at the left, Keon Penn, had severe sickle cell anemia. As a teenager, and they told him he wouldn't live to be an adult. Now, sickle cell anemia is a genetic disease. You can't use your own adult stem cells. He had to get a donor umbilical cord. He was treated. He doesn't have sickle cell anemia anymore. He also went from type O to type B blood after the transplant because of that little mismatch you can get, and it still works. Another example with sickle cell, Joe Davis Jr., in between mom and dad here in the picture, diagnosed at birth, and they couldn't find a match. But along came little brother Isaac, who was a match, and now the two of them are out playing together, playing golf, beating each other up, all the things that brothers do to each other. But I also came across a medical reference where they used this C word, curative. Adult stem cells, the only curative therapy now for sickle cell disease. dry scientific papers, olfactory mucosa autografts, but spinal cord injury, using adult stem cells to treat spinal cord injury. Here's one example, Jackie Raybon. Now, it's not a cure. She's not running any marathons, but was paraplegic and can now walk with the aid of braces. Silvio Folignani was quadriplegic, could move his arms or legs. 2 years after his accident, they took some of his adult stem cells, placed it into the lesion on his spinal cord. Now, he's not running a marathon either, but he can walk, he can wave, he can do a lot of things that he couldn't do before. And the adult stem cell source they're using from the patients, that olfactory mucosa, is some material behind your nose. It gives up your nose a whole new meaning for stem cells. Cardiac repair. Couple of again, scientific papers where they're actually seeing results with patients, but here's a face. Doug Rice, congestive heart failure, where he couldn't have walked from here to the other side of the stage. His own adult stem cells into his heart. We also were taking Doug up to the hill every once in a while, and he was wearing us out, walking all over the place. And any open door, Doug would go in. Let me tell you how adult stem cells saved my life. And it was a fact. The Germans are actually ahead of us. They've been publishing textbooks for over 10 years on how to use adult stem cells to treat heart damage. And I came across this in an in-flight magazine a few years ago. He goes, what if you could do this after a heart attack? And I'm thinking, this would give me the heart attack. But it's an ad, even though it's still experimental, from Emory University. Come in after your heart damage, get your own adult stem cells, get your treatment here. Stroke, here's one example. Roland Henrich was treated for stroke with his own adult stem cells. He came into Herman Hospital Trauma Center in Houston, paralyzed on one side, couldn't talk. Some of his own bone marrow adult stem cells just put back into his circulatory system, and within 11 days, no paralysis, and he started to talk again. And remember that promise of fetal tissue to treat and cure diabetes, and we're making all these great insulin-secreting cells with embryonic, but we haven't actually treated anybody successfully with those. We have with adult stem cells. Richard Bird, again, with a couple of his patients here, type 1, juvenile diabetes, off all their drugs, including insulin, after being treated with their own adult stem cells. Multiple sclerosis, here's some more of the little scientific papers. These just keep flowing again. But Barry Gowdy was at the point where his MS, he had trouble moving and so on, treated with his own adult stem cells. He's gone, I think it's 9 years now without a single symptom. Limbal stem cells, what are they talking about? Corneal regeneration. Well, at the very edge of your eye are adult stem cells that can reform the cornea over the front of your eye. And that's just what some researchers in Italy did. On the left is before, on the right after, and that famous term, as you can clearly see. But now the patients can clearly see. In fact, there was one man who had been blind for 50 years who could now see clearly, growing a new cornea with his own adult stem cells. Okay, and now it's going to start to get a little science fiction-like, but there's a doctor in Pittsburgh who's developed what he calls a skin gun. Literally, he will spray your adult stem cells over a burn or some sort of wound. It doesn't immediately make skin. This is not Star Trek yet. But in about half the time that it would take for the normal skin graft, this will start to grow new, fresh skin. And in the meantime, you've sealed it off, so you've got a nice aseptic or sterile covering. And this is one case where they were growing the tissue outside in the lab. Young lady who was going to lose her windpipe. In fact, her whole lung they were going to take out because the windpipe had been damaged due to tuberculosis. And they said, well, wait a minute, let's grow a new one. And so they took some cadaveric tissue, stripped of all the cells, essentially just some cartilage, essentially basted it with her own adult stem cells, grew this bit of trachea, this bit of windpipe in the lab, transplanted it back in. A week later, she walked out of the hospital. And they've done this now with a number of patients. So, patients are the real stories here. And their success stories over and over and over again. Like I said, over 1.25 million patients with adult stem cells. No human beings were sacrificed to get those cells. Instead, you're using adult stem cells to actually treat patients. We were able to convince Governor Brown back in Kansas to actually start an adult stem cell therapy center in Kansas in 2013. The Midwest Stem Cell Therapy Center is now up and operating. In fact, it started in July 2013 and in 2 months was processing patient cells and treating patients. And now they've got a number of treatments as well as a bunch of research, clinical trials, and preclinical trials going. And smiling Dr. Budadon here, who's the director, but they're on what amounts to a minuscule budget, treating hundreds of patients now, but it's again with adult stem cells. It's where the real success is at. This website we put up a number of years ago, actually when I was still here at FRC, we put it up, stemcellresearchfacts.org. I encourage you to go to this. You can go here and there is a spot where you can do that search for the different clinical trials as I mentioned before. You can look at some of the research that's been done, but the chief feature here is just telling patients stories. Because again, a lot of people have not heard. Adult stem cells, successfully treating patients, patients cured, patients alive now, their health better after adult stem cells. And again, I want to encourage you to go there, stemcellresearchfacts.org, and I want to end by showing you the most recent video story of one of the patients.
Met my wife, my lovely, beloved wife, in high school, just right up the road here.
Bill's a perfect gentleman, and they're few and far between.
Kind of like one of those things of love at first sight that never did quite subside, Well, I'm kind of a car nut, and I think I got that from my dad. I belong to the classic Chevy Club, and normally I'm full of energy and working on all kinds of projects.
He started taking naps in the afternoon, and I'm not talking a 30-minute little nap. He would lie down in the afternoon and just stay down.
I told the doctor, I said, Doc, my tail's really dragging these days. And then he decided to do a blood test, and the hematologist said that, yeah, you've got myelodysplastic syndrome, is what he called it. And I didn't know what the heck he was talking about.
It just didn't seem possible, and I thought right at first that the doctor had probably made a mistake.
I asked him, well, how do you cure this thing? You can continue with the blood transfusions, then we put you on chemotherapy. Then we go into just comfort care.
We knew that meant we're just going to make you as comfortable as we can in your final days.
Basically saying, then we just wait to die. Obviously, it was pretty darn depressing.
It was a very dark time. It was a very dark time in our life, and we even made an appointment with a lawyer to try to start putting affairs in order. Very dark time. We happened to meet our new neighbor, Tom, who had just moved in.
Mary came to me and she was sobbing, and Bill had been diagnosed with leukemia, and that they had been to a doctor. He had basically told them that there was no hope.
And I couldn't believe it. Tom said, I've had MDS, and I've had a stem cell transplant. And I can tell you, there's a doctor right down the road that does these.
Boy, I tell you, it was like a miracle to see the change in their faces the next week. When I talked with them, there was hope.
So everything here looks great. The blood work looks absolutely terrific. Your blood work is normal. Your lung tests are normal.
Well, you might say that I got a second chance, and I gave my old truck a second chance too.
He's back to himself, working on his trucks and doing things to the house and doing things at church, and he's himself again.
Adult stem cells are a lifesaver. I wouldn't be here, and Bill would have probably not been here.
I've got to say thank you, Lord, for saving him for me and for our children and grandchildren. So I'm just very, very grateful.
My name is Bill Borland, and adult stem cells gave me a second chance at a wonderful life.
Thank you very much for your time. And we've got a little bit of time to take a few questions, so if you've got one, if you could take the microphone so everybody out in the media can hear.
Mal Klein, Accuracy in Academia, and just so I have this straight, so Planned Parenthood gets about half of its $1.3 billion in revenues from the government and performs more abortions than Russia?
Yes, yes to both of those. It's 41%. It's not quite half, but it's a fair pot. And yes, they perform almost as many as some of those countries. Russia was pretty close to the total number in the U.S. 1/3 abortions a year, which is, again, they would be the sixth leading country. It's more than places like France and so on. It's a tremendous number. Others, yeah.
Yeah. Do you know if there's been any cure for Parkinson's or related to adult stem cells? Because I know Michael J. Fox was, when it was this whole stem cell debate was raging, he was a big proponent for embryonic, and he has Parkinson's himself.
Mm-hmm.
I was wondering if the adult stem cells have been effective for Parkinson's.
There have been like a couple of very small studies. In fact, one was just one patient, and it was effective. That particular patient, they used his own brain adult stem cells, and then he was kind of his own control experiment. So half of the brain got cells put back in, the other half not, and he went for 4.5 years with no symptoms. Now they started to come back, assuming either the untreated part just kept degenerating. Who knows whether the dose was appropriate and so on. They have shown some effectiveness. It's still kind of early for that. It's interesting that Mr. Fox was a very strong proponent of embryonic, and then his statements changed to he was in favor of all, including adult stem cells, and they did save one of the umbilical cords, I understand, from one of their children. Now, once the science kind of catches up, I'm sure they're going to want to get in line. Yeah.
How is all of this regulated? It's not a drug, it's not a medical device. These are all trials you've been talking about. What kind of blessing, if any, does it?
Yeah, it's a mixed blessing. FDA does regulate it, and actually at this point they treat my own cells as a drug, even if given back to me. So we're probably due for some reform in terms of cell-based therapy regulation, because right now I couldn't have someone take my bone marrow or even fat adult stem cells out and grow them so I had a bigger dose and come back in 2 weeks. They've actually shut clinics down that were doing that. It has to be within 24 hours. You can't do more than what's termed minimal manipulation, which is not defined. And it has to be back into me essentially during the same surgery almost. So, and the FDA has recently published guidance that might even shut some of that down as well. it really is in need of good reform now, because there are people that at this point are kind of chasing some of these things even offshore, because the FDA is not allowing some of the practitioners to do a trial even in the U.S. So we do need some changes on that. Any other questions? Got time for maybe one or two more.
Thank you for highlighting why stem cell research that's done from the embryos is ineffective. And I agree with you that it's also unethical. But I was wondering if you could explain as briefly as possible why it's unethical. Because I think we sometimes don't even agree necessarily as Christians on the whole that it's unethical.
Yeah, and we always want to keep, number one, the adjective on there, the embryonic as unethical, adult stem cells, the induced stem cells, those are totally ethical, totally illicit. The bottom line becomes, to get embryonic stem cells, you have to destroy a young human being. It's very early on, much earlier in terms of life than abortion, but even at a week after conception, you're still a human being. You're still, who you are at that point is who you will be later on, but you've got to destroy that young life. And it's simply unethical to sacrifice a life like that as an experiment. Yeah, Bethany. Bethany can have the last question.
That's my prerogative, right?
Right.
I actually attended a faith and law lecture a couple of weeks ago on very similar topic. But one thing that the speaker said that came as a complete shock to me, he said that many of the therapies that are being billed as coming from adult stem cells are actually from fetal tissue research, that they're being harvested, as you said, that there are adult stem cells present in preborn children. Are you aware of this? Or?
Yeah, and
okay.
I wouldn't characterize it as many. You can count on two hands at least the fetal stem cell trials, especially ones that are FDA approved. There are about 4 companies that are doing this, and they've been able to get FDA approval, just like the one group was able to get an FDA approval for the embryonic. But they are, in fact, it was interesting, as you mention it, one of the companies was trying to say that they were using adult stem cells, and you had to dig a little bit to find out that no, they were from aborted babies, aborted fetal material, and they were just kind of billing it because they were going with this sort of buzz about the success of adult stem cells. So you do want to do due diligence. Not every clinical trial approved by the FDA or NIH is going to be licit. But it's a small number at this point, and frankly probably will remain a small number simply because the adult stem cells work so well, most people are not even bothering to look at embryonic and fetal anymore. All right, well, thank you very much for your time. God bless.